Good day all. Let's look at another example of DC machine questions. Now this question says a shunt generator has an induced EMF of 280 volts. So we can even start solving. You have gotten an important information already. Remember, this is critical. It determines what equation or formula you'll be using. So our diagram, we have our okay. So this is our shunt machine. So for us to show is generator, our current will be leaving because generator converts mechanically into electricity or electrical. So at this point we will have our terminal voltage VT. We will have our load current around here, our shunt current around here, our armature resistance, our shunt resistance, our armature resistance, our generated or induced EMF, and okay, I think this and our armature current. Okay, so let's check it, what parameters we are giving. So they say that a DC shunt generator has an induced EMF. It has an induced EMF of what? 280 volts. That means our EG is what? 280 in volts. When the armature current is what? 60 ampere. So our armature current is what? 60 ampere. And terminal voltage is what? 247 volts. Our voltage here is 247. And we praise it. Assuming a brush voltage drop of 3 volts. Okay, so let us say that there was a voltage drop along this due to these two brushes. So let us introduce it. We'll call it VB is equal to what? 3 volts. Now this 3 volts will be adding to the voltage drop due to this armature resistance. Then our value of voltage at this point will reduce due to this one. Normally it's this is our generated EMF or induced EMF, but due to our armature resistance and this brush voltage drop, it will reduce to a particular value, but we don't know some other parameters for us to determine what that will be. Now they're asking us to calculate the armature resistance. Our armature resistance, we want to find it. We don't know what it is. Okay, now they didn't give us anything concerning this region, so I guess our equation will be focusing more on this other part of it. So we have that our EG, it is being generated, will subtract the voltage drop due to the armature resistance, and also reduce due to our brush voltage drop. Now whatever this value is whatever is going to be the voltage value at this point. How to be our voltage value at that point. So since we know it, whatever that voltage value is going to be exactly what this voltage is. which is what? VT. Now we are giving EG, giving IA, giving VB and VT, so we can just make R sort of formula from here. So let us take this guy over here and this guy over here. Then we have that EG minus VB minus VT is equal to IARA. Now dividing both sides by IA, we'll be having that. Now I'm going to be turning the equation all around, but it's the same thing. This will just come here, this will come here. That's only what I'm doing now. But we're going to be dividing all through by I. And when we do that, we have that RA is equal to EG minus VB minus VT divided by our IA. So this is, if we use this formula, we will get our ROA. So let us impute our values. Our EG, according to them, they say is what? 280. If we subtract it from our brush voltage drop 3 and our terminal voltage 247, then we'll divide it by what? IA, which is what? 60. So with your calculator, impute this 280 minus 3 minus 247 divided by 60. We'll be having 0.5 watts ohms. That is the value of our armature resistance. So we have gotten the first one to be what? 0.5 ohms. Now moving over to the second question. The second question says terminal voltage of an armature. Okay, so terminal voltage for an armature current of 40 ampere or 40 ampere. So they want us to get VT when IA is now what? 40 ampere, but the other parameters will still remain the same. Only what will change is our value of IA. We have gotten RA, we know what VB is, we know what EG is. We just simply use it to get our VT. Now, like we said earlier, our EG, which is the induced EMF, will subtract itself from the voltage drop of the brush and subtract itself from the voltage drop due to the armature resistance. All this will give us the value of voltage here, and since there is no resistance along this path, meaning that the voltage here is the voltage here, which is what? VT, which is our 247. Okay, sorry, first of all writing our, which is our what? Our VT. So we'll just simply just impute our values to get this. So we'll have our VT is equal to our EG. What is our EG? 280. Our EG is 280. Our VB is what? 3. Our IA is what? What our IA to be what? Now they say it is what? 40 ampere. So this value will change from 60 to what? 40. Now we're not dealing with 40. is now 40 ampere multiplied by our armature resistance, which we got to be what, 0.5. Now with our calculator we impute this. 280 minus 3 minus 40 times 0.5. This will give us 257. So this is our terminal voltage if we decide to change, if the current that was supplied was then 40 ampere. This is in volts. Don't forget to add your units. So we are getting our answer for the B part to be what? 257 volts. Now solving for the third part, the C part. The C part is now asking us, is asking, say the generated EMF, we should calculate the generated EMF if field current is increased to give, okay, let's write this step by step. E.g., we should find E.g. if field current is increased. Now we're not interested in this guy now. Field current is increased to give a VT, that's a terminal voltage of what? 320. So there was an increase in this guy that made our value here to become what? 320. When delivering an armature current of 80, so this time around we're not dealing with 40 this time around, but what? 80. So they want us to find our EG. We don't know what it is now. So we'll still use our formula, nothing is changing. Minus your VB minus your voltage drop due to armature resistance, and this all is equal to your VT. Now making EG sort of formula, we have that EG is equal to VT plus VB plus IARA. This is what our equation will give us. Now imputing those values, we have our VT to be what? 320. Our brush voltage to be what? 3. Our voltage drop due to armature resistance, we have gotten this value to be what? 0.5 ohms. So our armature current is 80, and our armature resistance is 0.5. Now all this will give us, compute with your calculator to get the value. 320 plus 3 plus 80 bracket 0.5 bracket close, and we have our value to be what? 363. So this is the answer we will get. So when the generated EMF, when our terminal voltage increased due to some change in this guy, but we don't know the value, and our armature current also increased to 80. It was no longer 40 or 60, it was now 80. So the thing caused our EG to now change to this value. So thank you and God bless you. Subscribe to the channel. Thank you.